Welcome to this video involving solving equations with multiple absolute value expressions in them. So when we have an equation that we want to solve looking like what we see on the screen, the first thing that we want to do is determine the key numbers for the particular equation. Now the key numbers occur when we look inside of a single absolute value and determine what value or values of the variable make that expression equal to 0. So for 5x minus 4 to equal 0, x would be 4/5. And for 7 plus 2x to equal 0, x would be negative 7/2. Those are the values, the key values, where the absolute value expressions can switch from positive to negative or negative to positive. So those are the values that are going to be key in determining the result of the problem. What we're going to do then is create a number line with those two values on it in, of course, numerical order. The number line is now pictured on the screen. And for that number line, now what we have are three sections that develop. We have this first section over here that I'll color in blue. We have this second section in the middle that I'll color in green. And then we have this third section over on the far right that I will color in orange. For each of those sections, we are going to approach the equation separately. And what we are going to do is something like this. We're going to say, first of all, in case 1, we are looking at values of x that are less than or equal to negative 7/2. So x is less than or equal to negative 7/2. Then when we are in this case, we're going to pick a value of x less than negative 7/2. I'll pick, let's say, negative 10. And we're going to plug it back into these absolute value expressions. So if we took x was equal to negative 10, just think about that. We shouldn't actually write it on our paper. And plug it up here, negative 50 minus 4 would be a negative 54. Inside the absolute value is negative. So in order to take off the absolute value symbol, we would have to change the sign on what's inside. So for this first expression, we will get rid of the absolute value symbols, but we will put a negative sign out front and then put parentheses around our expression. Next, if we plug in negative 10 for x right here, 7 minus 20 would be a negative 13. That also means if we were to take off the absolute values, we would have to change the sign. But make sure you leave the negative symbol that was in the problem. So this negative sign that I just highlighted in yellow has to remain, but then we really put another negative sign into the mix in order to take off the absolute value symbol. That's because inside the absolute value is negative. Removing the absolute value symbols means that a negative has to go in that place. And then we'll keep the rest of the equation as it is, just equal to 1. Now we will distribute our negatives, or in this case, it just combines to a positive. So we will have a negative 5x plus 4. Please watch out for that. A lot of times people forget or accidentally don't distribute the negative carefully. This turns into a plus, so we can just leave that as plus 7 plus 2x is equal to 1. Combine our like terms. Negative 3x takes care of the x's. Plus 11 is equal to 1. So a negative 3x is going to be equal to a negative 10. Or ultimately, this is going to mean that x is equal to 10/3. Please leave things simplified, ideally as an improper fraction. Now, before we circle that answer and say it's good to go and celebrate, what we need to do is take that answer and compare it back to the case that we were in. In this situation, x needed to be less than negative 7/2. Is positive 10/3 less than negative 7/2? Nope. That's actually what we would call an extraneous answer. So that would be no, it actually isn't a solution, and we would move on to the second case under consideration. So as we scroll over here, we're going to say case 2 is what happens when negative 7/2 is less than or equal to x, which is less than or equal to 4/5. So pick a value of x in between -7/2 and 4/5. The obvious one, the nice one, is 0. When we plug 0 up in this first absolute value, it would be equal to a -4. So when we take off the absolute value symbols, we have to put a negative sign out front. So it's going to be the opposite of 5x minus 4. Now when we plug in x equals 0 over here, this is going to be 7, which means we can just take off the absolute value symbols without changing anything. But if we're not changing anything, make sure that we leave that negative sign that was out front where it belongs. And then we'll finish off the equation, say it's equal to 1. Please be careful with distributing the negative. So -5x plus 4 minus 7 minus 2x is equal to 1. Combine our like terms, we get -7x minus 3 equals 1. So -7x is equal to 4. And x is equal to a -4/7. So now before we're done, we have to take that value of x that we got and compare it with our case. So if x turned out to be equal to -4/7, is it greater than or equal to -7/2? Yes. And is it less than or equal to +4/5? Yes. That means that x equals -4/7 will be a solution to this equation. And then we have one more case that we want to consider and that we need to consider. It's case 3. And when we look at case 3, it's what happens when x is greater than or equal to 4/5. So we're going to pick a value of x greater than 4/5. Why don't we go with 1? If we plug in x equals 1, this expression right here, 5x minus 4, is going to be equal to 1. That's positive. So we can take off the absolute value symbols and not worry about putting any sign out front. If we plug in x equals 1 over here, we get 9. Again, it's positive, so we don't change anything. But when we don't change anything, in other words, we're not putting another negative out front, we have to keep the one that was already there. So 7 plus 2x in parentheses, because we still have to distribute that negative, equals 1. So rewriting this, we'll get 5x minus 4 minus 7 minus 2x is equal to 1. Combine our like terms. 3x minus 11 is equal to 1. So 3x is equal to 12, or x is equal to 4. Again, compare. The easiest way to check is to just look back to the case. Is x equals 4 greater than or equal to 4/5? Yes, it is, so that solution would work. The other way you could check it, of course, is to plug back in the original equation. If we plugged in 4, this would be the absolute value of 20 minus 4, which would be 16, minus the absolute value of 7 plus 8, which would be 15, equals 1. And that does work. 16 minus 15 is equal to 1. Easier way to check it, of course, is to just compare with the case itself. And then please, please, please don't forget, on your work, I would want to see an overall answer indicated. So in this case, in this problem, we should say, the first case did not lead to a solution. The second case, it was -4/7, and the third case was 4. So when we go to write out our answers to the question, it was x equals -4/7 and x equals 4. Those were the overall solutions to this problem. As we've seen in class, there might be one answer. There might be two answers. There could be more than two answers. There could be no answers. Take it case by case. Watch for silly mistakes. But be attentive. Be thorough. Distributing negative signs matters. Being accurate matters. So do your best to stay organized. And hopefully, in the end, we will have the overall answer work itself out.